My name is D.V. Naidaskada and I am going to present a seminar on geophysics. So, introduction. Geophysics is a natural science that deals with the physical process and properties of the earth and its surrounding space and environment by using quantitative methods for their analysis. So, it's a multidisciplinary subject that categorizes the subsurface of the lateral and vertical mapping of physical property variations through technologies. So the next one we already know, that is the multidisciplinary subject, that is it contains geology, physics, maths, and also it's called as geophysics. So the components of the geophysics are there of three types, that is potential field, diffusive field, and wave propagation. For in the potential field it have gravity and magnetics, and for the diffusive field it has electrical, heat flow, and electromagnetics. For the wave propagation it has seismic and radar. So these are the branches of the geophysics, that is mineral geophysics, mathematical geophysics, solid state geophysics, biogeophysics, geophysical fluid dynamics, GEODESY, heat dynamics, geomagnetism, seismology, near surface geophysics, technophysics, borehole physics, geophysics, micro geophysics, and exploration geophysics. So these are the types of geophysical survey. That is, there are many types, many methods and types of instrument used in the geophysical surveys. The technologies used for the geophysical surveys include seismic methods, seismo-electrical methods, GEODESY and gravity techniques, magnetic technique, electrical technique, electromagnetic methods, borehole geophysics, and remote sensing techniques. The first one is seismic methods, that is reflection seismology, seismic refraction, and seismic tomography. So this type of survey is carried out to discover the detailed structure of the rock formation beneath the surface of the earth. The next one is GEODESY and gravity technique. It includes gravimetry and gradiometry. So this type of survey is carried out to discover the structure of the rock formation beneath the surface of the earth. The next one is the electrical technique. It includes electrical resistivity tomography, induced polarization, spontaneous potential, and marine control source electromagnetic or EM seabed logging. So this type of survey is carried out mainly to study the existence of the groundwater. The next one is the electromagnetic method. So it includes magnetotellurics, ground penetrating radar, and transient time domain electromagnetics, surface nuclear magnetic resonance. So what is the future research means? So it involves in the DL, that is deep learning in the geophysics, such as unsupervised learning, transfer learning, multimodal deep learning, federated learning, uncertainty estimation, and active learning. So the geophysical surveys for the oil and the gas exploration. So when any operator company own the exploratory block for the hydrocarbon exploration, means they first have to know that whether the seismic survey is done in a particular area or not. If the survey has already done on the block, then the new operator company acquire that data for further knowing the prospects regarding exploration of the hydrocarbon reservoirs. So what are the major type of seismic reflection survey, or the 2D and the 3D? So the 2D reflection survey means the reflection of the elastic waves at boundaries between different rock formation, especially as a technique for prospecting or research. So the types of the seismic surveys on the basis of the terrain, so the onshore land survey and offshore ocean or sea survey. So the types of the seismic waves are of two types, that is P waves and S waves, and also is contained the rest of the waves are called relay waves, that is called as L waves, surface waves, or ground rolls. The next one is the 3D seismic reflection survey. So it is very expensive compared to 2D, and it's always carried on in confined selected areas. So the cost of 3D acquisition, processing, and interpretation increases significantly, but in return more chances for successful exploration possible. So after the 3D survey, the geoscientists are able to interpret the earth interior structures in more detail. The resolution is also improved through the 3D survey, and 3D survey enables to show the complex small structures as well. So the benefits of the geophysics are the non-destructive without destruction. Efficiency means have to evaluate a large area for comprehensive different methods to solve complex problems, and cost effective means evacuation is not required. So for the uses of the geophysical methods, of the mapping large geological areas in order to increase our knowledge of the earth's structure, and locating and recovering resources such as hydrocarbons, minerals, and groundwater, mapping potential seawater deposits on the subsurface, monitoring seawater injections in the subsurface, and archaeological surveys. So the applications of the geophysics is estimating positions of the underground objects, array processing for seismographic applications, and visualization of the 3D data. So my conclusion is the geophysics of geophysics is a natural science that deals with the process, that is physical process and properties of the earth and its surrounding space environment by using the quantitative method for their analysis. So and the uses for the geophysics is the mapping of large geological areas in order to increase our knowledge of the earth's surface. And some of the branches of the geophysics are the mineral geophysics, mathematical geophysics, solid state geophysics, and biogeophysics. So thank you.